Okay. Okay with everybody to record? All right. I need your permission. By the way, you signed your permission already when you signed up for the course. Oh, we're now called Manhattan University. Oh, my goodness. Heavens. My head is exploding. There we go. All right. They seem to think that will help. I hope they're right. Okay, now let's get back to this. So this is the sheet that I will be sharing with you on Moodle. And what did we do? We created, first of all, defined range or defined names using create from selection, which you can find in formulas. Okay, so we did that. Create from selection, top row. Okay, good. And then we create, let me do it again. We created an array using that piece to this for this application. The data for the application is completely contained inside of Q. That's the data, the input data. And now we want to create an array of this, and definitely look up the array functions um, in Wayne Winston. And in column U, just to illustrate, I'm going to make an array. Now, the first step is to select the array size. In this case, I want all 12 rows in this one column. So I just did that. And I use keys to do this, okay, down keys and so on. Um, I'm going to say don't use the mouse. Get away from using the mouse. You will make mistakes if you do use the mouse. At least I do. And we've seen that. And now I want to put an array in here. What I need to do is, you can do it right here in the formula bar. That's the most reliable place. Equals numbers. Because we have a piece of data, an array called numbers, and that's the visual uh, icon for this. And do not press enter. Do not, do not press enter. But do press shift control together, enter. And you've now created an array. Similarly, over here, we can create another array, which is 1, 2, 3, 4, 5, 6, a row vector, one row by 12 columns. In order to do that, I'm going to have to learn how to count. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. And this is another array selection, but we're going to use an array function called equal transpose, oops, open parentheses. I usually put a space just to make these things easier for my auditor to read. And I'm going to put in the name of the primary data. I could use that. I could use this. What's in U, but I prefer to use numbers. There it is. Close parentheses. Do not press enter, but do press shift control enter. And there you get that second array based upon not the first array, but based upon the primary data that's going in. This is good spreadsheet engineering. Okay. And then I can use these to create all sorts of interesting things. Um, I could do a multiplication table. I can do an addition table. I can do a ratio table. I could do a binomial coefficient table. Does everybody remember the binomial model? Oh, I got to see your faces. The binomial model? No, we're not going to do that, are we? That's stats, isn't it? Right, John? Yes. The binomial model. Uh, N choose X. Okay, it's a counting. All of statistics is counting. Very creative counting, but counting. And I'm going to have a whole unit on that, not in this course, but you can browse through that. If you know how to count, uh, uh, you can run a warehouse, for example. All of the warehouses run on counting schemes. You have 10 items uh, uh, from 3 categories that have to fit on 4 different shelves. That's a counting problem. How do you put all the arrangements of that together? Uh, and then we can use that to help do resource allocation, among other things. We use it for scheduling, we use it for all sorts of things. Counting problems. All a probability is a counting problem. Okay, so there we go. Very simple. If you know how to count, you can do probability. Very simple. Um, you don't have to know advanced calculus to do it. Advanced calculus comes from knowing how to count. But we won't go into that. What we will go into is this. So, what did we do? We did equals this number times this number. Okay, that's not too hard. But if we wanted to copy and paste this, and if you just copied and pasted this down, oh, what happened there? Okay, didn't like what I was doing. I don't know why it didn't like what I was doing, but I must have done something silly. So equals this times this. And if we were to copy and paste this, we get a weird thing, right? And that's because we did not fix. It's looking at things very oddly. Um, okay, like this one comes from V8 and W7 comes from this number. This is not what we want. And the answer to this problem is we fix the column and then we fix the row because those are the 2 inputs. So we're only going to look at row 2 and column U. So let's see if that works, and we know it will. Yeah, it does. Okay. So we just built an associative table. And the first task of almost all analytics is building an associative table, is to associate one factor with another. In this case, it's with itself. Okay, and we get this kind of a table. All right. We might have levels of uh, mean rates of time spent on a process in this column, in this very first column, and relating those mean rates with the variation in the rates, which might be across this column. We're doing an associative analysis where this is in finance, this would be return, and this would be at the top risk. In operations, we get the expected level of service. And up here, we get variations or the predictability, volatility of those expected levels of service. So you can use this in a lot of different ways, a lot of very interesting ways. Okay. So that was exercise number 1. My challenge to you is, can you build a binomial table with this? Now, the other thing I always insist on is this table is hard visually to look at, isn't it? Would you agree? If you just saw this table, you go like, what's going on? What I tend to do is, by the way, I just use the shift control right arrow to do what I just did, is I format tables. I drive people nuts with this. I'm not a detailed person at all, except when it comes to programming, and I drive myself nuts. Okay, I did shift control down arrow there, and I format it. And then I'm going to do shift control right down, and I'm going to put a box around this. And now it's tidy. Yes, I have Canadian in my background. They love to use the word tidy. It's also a European thing, I found working with my European colleagues. Uh, we have a whole programming environment called the tidyverse in R. I program a lot in R, but and I'm not a programmer, never having taken a programming course, so I can't call myself a programmer. But you end up learning how to use this stuff out of necessity. And now it's tidy. It looks like a table, right? So, 3 principles of spreadsheet engineering here and now. Defined ranges, defined names. Name it, fix it. Okay, that was numbers. Second, arrays. Use arrays to transfer with data referential integrity primary data, which is in numbers, to an analytical model, which is what this table is. It's a model, okay, which is what we did, numbers. And then further, using transpose, always using that data, that primary data as your thing. If you change that primary data to something else, like we might do right now, just to make life interesting, we might go from here. We might go from here to here. Look what you just did. I changed the top number from 12. Look at how I define the numbers, though. Very clever of me. Yeah, not really. Okay. So, and now my table has changed. Okay. My table has changed. And you could do this. All right. This is why you do things like this. Data referential integrity says whatever's over here has automatically transferred itself here and now into the analysis. This is what our slide bars will effectively be doing, and what our data table will effectively be doing. Okay, we have somebody else coming in. Bring them in. So, a simple problem. Let's admit Sophia. Welcome, Sophia. Hi, Sophia. A simple problem, lots of interesting features. Please use these features. Get used to using these features. It'll save you time, money. It might save your job someday. Might save one of your colleagues' jobs someday. Might save the life of a customer or a client or a patient. Okay, that's the idea here. Let's safety first on the job, and that means using spreadsheets. That's one of the technologies we have. We must be very safe with our technologies. No slips and falls here. Okay. Oh, much better. Okay. Uh, you have time to do one more? Want to do one more? Okay. Are you finding this interesting and helpful? Are you having? Is it fun and educational? Okay. No, it's not fun. No, no, not at all. But it might be educational. All right. So let's look at another one. Um, and my challenge to you is to do exactly this associative table with the binomial coefficients. Okay, try the binomial coefficients. N choose X, row choose column, right? Gonna be the same idea. and you will build something called Pascal's array, which is probably at the foundation of, oh my God, is that the foundation of the cosmic universe? We're finding that Pascal's array, the binomial coefficients, are the basic numbers underlying just about everything in quantum mechanics. So, yeah, the whole universe. Okay, there we go. Kind of interesting. Yes, learn how to count. Um, I got one more here. I have something called, well, I have dynamically named ranges. This is a cool one, but I'm not going to go over it. And cut points is yet another one that I've used. I think I pulled this one in from Wayne somewhere, where you have different cut points at different levels of something called gallons. These are the thing, and prices, and you work out cost components. Very, very interesting. And if I put in 400, what would happen? Oh, interesting. Because you have cut points, and I put in 400 gallons, that's my primary data. Uh, it searches automatically through the cut points to figure out what the cost will be. Okay, um, let's put in 1,000 gallons. Yeah, good, very good. Okay, so cut points is useful, especially when you have ratcheted levels of, in this case, price per gallon. This is the discrete universe that we actually operate in. Dynamic named range is a little bit more complicated. We have months. We have sales each month. Um, we're using something called sum if, and this is a good one to look up. We'll probably do this next week because I'm going to expand this to sum ifs. Taking something called the date, which is probably the month, putting a condition. If date equals what's ever in E2, that'd be Jan, pull the sales. Okay, and sum them up. Oh, we have two Jans. Look at this. We've got 10. And 40. How come we're coming up with 45? Oh, 20 and 15. They do add up to 45. So it knows how to pull from here. It literally is doing a filtering of sales for anything that is Jan and then adding up those elements. How clever is that? And yeah, we can do this with index and match as well. Kind of interesting. But I use this in a lot of different applications. And the thing is always read like this: if date equals whatever is in cell E2, find the sales and add them up. That's the English language version of this piece of code. The harder one to do is something called expand grid. I have two scales, scale 1 and scale 2. This might be mu, and this might be sigma. Notice things change properly. Nothing's hard-coded. Oh, that looks interesting. And the mu might be 5, 6, 7, 8, 9. Notice things changed. So levels of, I see 5 people on average, 6 people on average per hour, 7 people on average, 8 people on average, or 9 people on average per hour. The variation that I have 3 levels of variation: a low, 1 person per hour; a low, a medium of 2 people per hour; This is in variation. This is a sigma, standard deviation for some of us, and 3 people per hour. I need to make a grid of 5, 6, 7, 8, 9 by 1, 6. Okay, and the other way to think about it is 6 with 1, 6 with 2, 6 with 3. This is called an expand grid. Look at the result over here. I have something called an index from 1 to 15. The grid length is 15. Okay, that's a reasonable one. And I'm starting with 5. So notice what it has in the first level here. 5, 5, 5, sigma. So 5 and 1, average of 5 people per hour with a range or variation of 1 person per hour. 5 people per hour with a range or variation of 2 people per hour. 5 people per hour on average with a range of 3 people. These are 3 separate hypotheses about my operation, which involves seeing people per hour. Okay? And it introduces risk or uncertainty. They're really different things, but called sigma. So I parameterize that. You can take a multiplication of these two to get different multiplications. But I'm going to do something different than that. We can use just use the times here, just to get an idea of times. Okay, actually, I'm going to take the ratio of mu per sigma. There we go. Control C. Control Shift down. Control V. Oh, let's format this a little bit with number. Now, those of you who remember your stats, do you remember the coefficient of variation? Anybody? Coefficient of variation? So it's scaling one thing by another. If we scale, and scaling is a very important part of analytics. If you scale the average number of people you see per unit of variation, that's a scaling of the average by the standard deviation, mu over sigma. We use this in finance a lot, this kind of scaling. It's return per unit of risk. Okay, that's the idea in finance. And the idea in operations is relative to all of the variability of an operation, what do you see on average? So it's average units of hours of operation relative to the variation in that per unit of variation. It's a scaling. Okay? And again, it's used a lot. The Z-score. Remember the Z-score in statistics? Yeah, mu. Okay, it's x minus mu divided by sigma. It's the same kind of scaling. Okay, puts everything on an equal basis. Accounting uses this all the time. Common size ratios allows you to compare a large company with a very small company, large revenue company with a very small revenue company. Amazon was that way for years, and then it exploded. Yeah. Same with Microsoft. Okay, so we're learning something new here. I hope. Let me put that variation in there. So I'm going to say mu divided by sigma there. And these are all the variations. So it's 5 per 1, 5 per 2, 5 per 3. So the riskier shows no longer a 5. The riskier is equivalent to that many standard deviations from this. Okay, that's the idea. And it's a scaling. So 6, 3, 2, 7, 3.5, 2.33, 8, 4, 2, 9. Okay. Now, why did I got to ask you a question now? Why 15? There are 15 hypotheses here, each with a different mu sigma combination and coefficient of variation, scaling mu to sigma. Some people define the CV, by the way, as sigma divided by mu, but we're not doing that here. We're doing it more from this scaling point of view. Your expectations relative to your level of uncertainty. Why 15? Any thoughts? Why not 16? Why not 14? Again, analytical questions. Your boss asks you, your supervisor, your colleagues, your client, have we considered everything here? Have we considered all the combinations? And you can answer quite truthfully, yes. If you accept the range 5, 6, 7, 8, 9 as all inclusive, and low, medium, and high as all inclusive of sigma, then there are 15 combinations, correct? 5 times 3, the count of 5 times the count 3. 5 times 15 combinations. And the expand grid works out all of those combinations. So we have a new analytical tool here, which ensures that if your input data is comprehensive, you have therefore considered all of the possible ways mu and sigma inputs can be combined to form 15 separate hypotheses about, let's say, a decision that you're trying to make. Okay, and that's another tool that we have. Now, how do you construct this is another question. I have some interesting things here. See if I can bring those interesting things up. Sequence 1, I'm not sure why I try to remember why I have that in there. We'll see. So the first IDX stands for index. That's an old term. We used to use that a lot. IDX. Because we were very constrained in the size of our programs. We could not, our programs couldn't be very large, but it's also easier to read. IDX underscore start. So another principle here is we use naming conventions that we agree upon. Okay, this is sometimes called a snake style, where you have different reticulations. Each reticulation is separated by an underscore. Okay, there's a reason for everything here. So we have IDX, and then anything about IDX will be IDX underscore, in this case, start. Oh my gosh, where does IDX start? Well, here's IDX start over here. Yes, IDX start is 1. We could make IDX start 3. Watch what happens. We have a mess. That's what happens. Because IDX start somehow is related to IDX end. We have the end. Here's the end. Here's the start. So we can define ranges. This approach allows you to do zoom ins and zoom out on a grid. Okay. on a grid. Very interesting. Now let's start with 1. Again. Okay, there we go. And you still got to answer the question for yourself, why 15 and why that is. The engineering principle here is called MECE, M-E-C-E. Mutually exclusive, comprehensively exhaustive. We've exhausted all of the and it's all comprehensive. And they're all mutually exclusive. These are all mutually either or combinations. Yeah, very logical. Logic is at the core of everything we're doing here. We either have both and, or we have either or. Either or, we tend to add. Both and, we tend to multiply. Those are the counting principles. Okay. And building grids is an important part of the counting principle here. We don't need that there. Okay, so we created 2 named ranges here, defined names. Go to formulas, create from selection, use the top row for the name, yes, and there they are. And we can check that they're over here. IDX end, there's IDX end, and IDX start is there. Okay, see it popped up. Okay, so we know that that's all there. We'll call that the Lisa Dominguez principle. Check your work. Notice I've used formatting to help me distinguish different things, such as base data here. This is all base data. I don't know what this is. Oh, this is very cool. Very cool stuff. Doing a count. Yeah. Okay. Don't worry about that sequence over here. But this is very cool. If you understand this programming, you are like, oh my goodness, you can do all sorts of things. It uses a count function, it uses an if function, and it uses an if error function. And it does some really interesting things with IDX underscore end and 2 other things. This is officially called 2, or I'm sorry, 1. We're going to keep that. And that's officially called 2, even though I've labeled them differently. Okay. So this is a reuse program right now. That's okay. We can do reuse. Here's the IDX. Let's look at this first one. How is it that we keep the 5s until we have exhausted the 1, 2, 3, and then move to 6? How do we move to 6 and keep the 6s until we've exhausted the 1, 2, 3, and then the 7, then the 8? How do those clusters occur? And by the way, you can create this in a pivot table too. Yes, you can. But look at the trick that index match does. And if you're not absolutely floored with the beauty of index match, I don't know what in Excel could be more beautiful. Okay, it's not that beautiful. And notice we're using something called sequence here. Sequence is 1, 4. That's the cut point. 7 is the next cut point. In other words, cut point. Cut point. I'm just going to, don't do that. There's the cut point. There's one cut point. The next one is 7. The next one is 10. It's very clever programming here. I did not invent this. I learned this from somebody. The final cut point. Okay. So these are the points at which 5 transitions to 6, 6 transitions to 7, 7 transitions to 8, 8 transitions to 9. Wow. my head is exploding already. So knowledge of these transitional points seems to be how you go from here, index 1, match E4, sequence 1, to here. Same formula, index 1, find in this index 1 means look up in here the number that is the row E5, okay, 6, okay, that matches the row number of sequence, and use 1. Now 1 is greater than, okay, greater than that number. So when you go and learn match, learn it with this example. You will learn a lot. But, there's a lot of other things you have to learn in this example. For example, this 1, 4, count plus T2. The count of 2 plus T2 is less than index n is less than 15. So what is the count of 2? The count of 2 is, well, let's write it out here. Is 3. That wasn't too bad. Okay. So if the count of 2, which is 3, 3 plus T, okay, 3 plus 1 is 4. If 4 is less than 15, which it is, then put here the count of 2 plus T2. Otherwise, put a blank. Okay. Now the count of 2 plus T2 is 4. Okay. Put that number in. Okay. So it's using these cut points, which are these cut points over here, as a marker for the transition from 5 to 6, 6 to 7, 7 to 8, 8 to 9. Hard to get at Saturday morning. I don't know how you're getting your heads around this. You have to work through this. Okay, I'm just kind of presenting some ideas here. And we go from here, index 1, match E4 sequence 1, and it's greater than. Okay, let's just figure that out. Why does that return 5? Well, E4 in this case is 3. Okay. E4 is 3. Let's do match first. Match E4 sequence greater than. That's the 1. That's what the 1 means. So let's just do that and see what we get. Now match returns a row number. Some row number inside a sequence. So there's row number 1, 2, 3, 4, 5. There's 5. That's the row number will be 1. Okay. The row number will be 1, 2, 3, 4, 5. So everything looks like a vector or a matrix to Excel somehow. And it does know row numbers. So the row number here for 4 is 2. The row number for 1 is 1. The row number for 7 is 3. 10 has 4 assigned to it. So that's how Excel knows what's going on inside of this thing called sequence. You see it comes up here, sequence. It knows locations that way. It's all data. Yeah, exactly. So let's do this again. Do a match. We're going to get a row number equals match. Find the row number is what match is doing. E4. Look for the row number where E4 occurs in sequence, where it is greater than this number. And it's going to be row number 1, row number 1. So sequence is always going to be 1. So that's the match. That's the row number. Okay. Now pull that row number, which is 5. That's the row number over here for mu in 1. Okay. So index look inside of I hate that when that happens. Let's do this again. Equals index, open parentheses, in the array called 1, which we have relabeled mu. Look, it's asking for row number. The row number that we just computed right there. And we will get a report of a value. The value is 5. It will report back to us, given that we want to stay in row number 1. Now, what happens down here? Okay. When we're at index E5, which is 4, we're at 4, we're at the cut point itself. Okay. We get a different row number. It's row number 2. And if we were to do the equals index of 1, look inside of 1. That thing that just got highlighted on the left. Look at the value in row number 2. And we get 6. So that's why 6 appears. Okay. No magic, a lot of logic. Huge amount of logic. Be interesting to map out this logic, actually. And how does this work? Oh, mod. Does anybody remember modular arithmetic? No? Okay. And look at what this is doing. Mod G4. So it's taking the previous one. Count of 2 plus 1. So if you don't remember modular arithmetic, returns the remainder after a number is divided by a divisor. Okay, that didn't help too much. Number and divisor. The number is, I can't remember what the number is. I'm pretty sure it's 3, but let me look at this. The number is the previous number. So I want to know, I'm trying to get just 1, 2, and 3 here. That's what I'm trying to get. But I'm going to use mathematics, arithmetic actually, and modular arithmetic, remainder arithmetic, integer arithmetic, excuse me, to do this. And again, this is another very, very important part of how we do computations in general. And I'm not going to ask you ever on an exam, because we don't do exams, but this will help you understand how these things get created and may give you some insight into how to create your own models as well. So I'm just going to run through this. It's mod G3. So let's do that. It was mod G3, count of 2. The count of 2 is 3. So take 3 of G3, which is 2. 2 divided by 3, and look at the remainder, okay, and report the remainder, add 1 to it. Now, somebody who figured this out was playing with this. They knew there's a modular way of doing it because these are all integers. So we take G3, which is 2, divide it by the count of 2, which is 3. So that's 2/3. 3 into 2 has a remainder. Let's see what the remainder is that's going to be reported here. You probably figure it out yourself. Mod G3 count of 2. My thumb hits the is brushing by the mouse pad. It's very sensitive. I might be just sneezing into the mouse pad. Don't use the mouse pad, right? Okay, mod G3 count of 2. You get 2. Okay, you get 2. And then you add 1 to that. You get 3. Integer arithmetic. It returns 2. Let's see if we can do this. And this is using finite fields in math, which is the core of all computation inside these machines. And you get a value for this one because the previous one doesn't, it's just the same. It's just a 0. There. That would be 0. And then if you add 1 to each of these, yes, it's a math class. You get 1, 2, 3. Okay. And that'll work all the time. Now it's interesting that this will take 3 and return 1. That is fascinating that should happen. Three is outside of the count of 2. It's outside of the 0. Count of 2 is 3 elements. That's a field, prime field of 0, 1, 2. All right, so that's what's going on in the math behind it. So it's going to return a 0 because 3 is outside. It's going to return a 0. And if you don't understand finite fields and modular arithmetic, you won't explode. Nothing bad will ever happen to you. But it is a very useful trick inside of these programs to know how to use mods. All right, we'll leave it at that. Hire somebody who can do it. You can see that 0, 1, and 2 are equivalent to 1, 2, and 3 in our setup. Okay, the 1, 2, and 3 over here. We did several things here. Okay, we're trying to understand these index matches. Index is a lookup in an array, and look up the match, which is a row number in another array. Look up the same, okay, so you get that. And then we use the greater than here in order to use a cut point for the different transitions from 5 to 6, 6 to 7, 7 to 8. We knew what we wanted to build here. We just want to automate it. And yes, you can hard code this. Yeah. We used count. We used an if statement. So what you do with these is you inventory all the things we've done. We've used named ranges. We didn't use arrays this time. No, we didn't have to use arrays. There might be some simplification that we can do with arrays, by the way, but be careful of that. We used index, match, if, and we used, what else did we use? Count. Anything else? Mod. Oops, not odd, although it is quite odd. Mod. I don't think we used anything else. Oh, yes. If error. If you went back and looked at all of these different areas inside, oh, let's get this up there. Still looking at odd. Inside of Wayne Winston, or just look up mod this way. I just from the looks on your faces, you didn't expect this, did you, today? No. So, oh boy. Okay, there we go. Ooh, informing decisions. This is my. I'm putting all of the class onto this website I have, but don't look. You don't need to see that right now. You do need to see this. The mod function. I do this all the time because I forget syntax. I don't remember the number and the divisor. It returns the remainder after number is divided by divisor. The result has the same sign as the divisor. Example. And they give you an example. They don't tell you why it works or why it should work. In which case, you dust off finite fields modular arithmetic, or you ask your favorite robot to give you an answer. Oh, finite fields. Oh, look at that. Got a whole thing here. Oh, no, not polynomial. Oh, no. Oh, my God. But this is actually what's inside of your computer right here, what I'm showing you. It's all polynomial work, which is equivalent to binary inside of your computer. I am so sorry to have to inform you of that. But, look at all the finite fields. Okay, this is what I have had to learn over the years because it's extremely important to the work I do inside of multimodal estimation. In other words, what you see on a survey, that's multimodal, all those survey answers. Look at that. Oh, C programming example, a D. I didn't know there was a D programming. That looks like, oh, okay, so you got all this stuff. So yeah, that's a little bit too much. Yeah, that's too much information, TMI. But modulo, there we go. That's what I'm looking for. Modular arithmetic, which gives you, and you use clocks. Timekeeping is using modular arithmetic, for example. That's the best example we have. A clock is modular arithmetic. 1 modulo 12. And then you get all this other stuff. Oh, no. But here you get some examples of, 38 mod 12 is 14. It's the remainder. Okay. See, 38 minus 14 equals 24 equals 2 times 12, a multiple of 12. There we go. That's the remainder thing. It's doing division. All right. So I'm going to leave you with that. Probably leave you in the dust here today, but hopefully not. Okay. So we did all of these things. Check them out. I will drop this into Moodle. Um, the This will be on the video will probably process in about 30 or 40 minutes. If I'm still around, I have some errands to do. I will install that, give you the site that you can draw it down on. But basically, if not listening to my droning on here any further, if you simply followed through on all of these, what the heck is going on here? What the heck is going on here? And you always work from the inside out. You don't do if error. You don't do if. You work from count 2 plus T5 less than index n. You work from there. You work from count 2. Add T5 less than this. This is it. Is it true? Yes, 1. No, 0. It's all logic. And you work from the inside out. The same with this odd thing called the mod function, okay, where we did over here. Mod, divide by, add 1, always give you this. Because look, it's a finite field of 3 elements. And we get equivalent 1, 2, and 3, because finite fields always start with 0, 0, 1, 2. And this is low, medium, and high. We use these kinds of scales all the time. That's why the only reason I wouldn't do finite field arithmetic for love or money, except that it helps me understand how to do estimations of ranges like this. 1, 2, and 3. There's nothing between 0 and 1 or between 1 and 2. Mutually exclusive. Okay. Multinary. This is trinary. Binary. Okay. Leave it with that. Finally, see if I can find my. There we go. And there you all are. Okay. So I'll deposit this spreadsheet into Moodle, and you can play with it. You can take pieces of it. You can just spend all your time in Winston on match. Do a bunch of matches, do a bunch of indexes. We will be using these as we go forward using spreadsheets, but it's more the logic behind it. I wouldn't use any of these except they help me with my logic and building a model. Okay, very mother of invention approach. It's more discovery than anything else. I hope this was helpful today, a little bit. And now you're going to drop add the course. I can tell. I can't do this now. Oh my God, I'm exploding. No, just take it in little pieces. All right. That's what I have to do. I just did that in front of you. Okay. I was in a very precarious position there for a couple of minutes, but you just work through it. You troubleshoot in pieces. Troubleshooting is going to be your middle name in building models. Even the ones that work, and then you're trying to replicate them. You think, wow, it didn't work. Why? Start from the inside, work your way out. It's probably because you didn't refer to something, you didn't name something, you didn't make an array of something, you didn't do some very simple primitive operation when you thought you had. Okay. Any thoughts? Sophia, you remember all this from class, right?
Yes.
Yes, and it's happening all over again, deja vu. Yeah.
I'm so excited.
I'm glad. Just sit back with this, okay? Very good. Okay, great to have you all. in here, and we'll be having sessions like this. Hopefully, you will be next week, looking at some things I can't do yet. But how do I do them? Questions. Okay, we can do that together.
Professor,
Yes.
can I ask two questions?
Yep.
First one, where can I find today's Excel from Moodle?
Oh, I will put it in a message to everybody. I will load it into a message that you will receive in your email, and I will put it as part of. Wait, oh, I don't think I have Moodle on here. Let me show you where I'll put it. No. Let's see if I can find it quickly. No. There it is. Can you still see my screen?
Yes.
Yeah. They didn't change it to Manhattan University yet. Oh, my. Oh, I'm sorry about this. We're using two-factor authentication now. This is probably a good thing. That's one factor. Okay, let me show you where I'm going to put this. What's a decision? We're in week 1. I'm going to put it right here, okay? So now you can see me making the vegan sausage. Okay, pricing of pie. Raffensperger is quite good. It's still 2001. I can't do a better job than that. So go. All right.
Thank you.
You're welcome. That was question 1, Yumi. You said you had a second.
Yes, I want to ask about the one assignment to sharing the model. I'm not seeing the Winston's and notes, and actually I'm not very sure to which data would I use.
It's just replicate. Do you have Winston?
Yes.
Okay, just go to the index chapter.
You mean the inside textbook or data?
Yeah, it's inside his book.
Okay.
And go to an example and do the example yourself. Okay, in a spreadsheet. Don't read it. Do it on a spreadsheet. That's the assignment.
Where can I see them?
But you have Winston at all?
Yes, on digital.
Okay. Share your screen if you have Winston up running, so everybody can see that.
Now I'm opening on tablet, so can you give a moment?
Okay, no problem. I don't think I've got a copy of it right here. Oh, my copy's upstairs, and I don't have access to a digital copy at the moment. I don't see it. So just go to, the chapter, go to the chapter in Winston on index. I don't know what chapter that is. You can go to the chapter, it's labeled how to use index or something, how you answer a question. Do you see that?
Now, yes, can I show
Yes.
share the
Definitely. Go ahead and share. Let me,
can you turn off your share screen?
yep, go for it.
Thank you.
You're welcome. Oh, beautiful. So down a little further to the table of contents. Okay, index function, chapter 4 and chapter 5. There we go. So the idea here is to see what he's doing here and simply replicate the example. This one here does distances, okay, and adds them up, going from one place to another. A very common problem.
So
So
we're gonna
that's
make only this table
right.
chapter 4, right?
Yeah.
Do I use the EndNote? I mean, these, let I show you.
Yeah, you see how he's doing it. He's naming a range called distances, and he's looking at row 1, column 4. So he's looking at row 1, column 4. That's what he's referring to in the text. And the next one, he's looking across the distances and looking at row 6, column 8.
Okay. I mean, I want to ask, I have to use these data. So wait a second. These data.
Yes, beautiful.
Yeah.
So it would be in 1 to 60.
Mm-hmm.
It'll be in 1 to 60. There we go. There's 4. Okay.
Then
Yep.
there are 3
Yeah,
files.
yeah. You can use any one of these. You can just use the practice files.
Practice files.
Yep.
Then
And any one of these, the product, the index, the NBA. He was talking. Yeah, for example, the product is a good one.
Can you see the data?
You should be able to if you click on it.
Change.
Double click on it.
This one?
There you go. And so you have 6 products arranged across 6 months.
Yes.
And he'll go through the example of how that works. And what your job is to replicate that with this data.
Okay, replicate on the other sheet or
Yeah, his replicate his discussion of what is the question that's being asked, and how would you use index or index and match to answer the question using this data. That's the idea.
Okay. All right. Okay.
I hope that helps a little bit.
Yeah.
Okay, good. Yeah, having all those files of data, that's wonderful. Otherwise, you'd be typing it all in yourself, which would be very difficult.
That's hard.
Yeah. Okay. And play with it. All I can say is play with it. Don't go crazy, but play with it. Try something, break it, put it back together. And that's the only way that any of us get any of this done. Yeah. Honestly, I had to look up index again to recall exactly. There was a feature of it that I couldn't remember, and I had to look it up just to make sure. Oh, that's right. Yeah, because I don't use it every single day. I don't use Excel every single day. every other day maybe. And I forget things. I'm in some other computing environment that's totally different than this. And you just don't remember things. But we learned a lot today, I hope. Okay. Any other questions? Those are good questions. Thank you. Okay, all right. Well, I'm going to ask for a motion to reconvene next week at the same time, same Zoom channel. All right. Any discussion? No. Do I have a second? No seconds? Okay, good. Thank you, Aaron. All in favor? Aye. Okay, good. Great. Thank you very much for your kind attention. We have so much to learn. It is just wonderful. And it's wonderful to have the opportunity to work with all of you. Thanks very much and see you next week and have a great week. Holler if you need anything. Okay, you can text me. You can also put stuff up on the wall, questions, all right, so that your colleagues can help you. And you can also, I'm one of your colleagues. I might be able to help you. All right. So take care, and I look forward to your first submissions. Okay. Thanks, everybody.
Bye, everyone.
Thank you, Professor. Have a good one.
Thank you,
Thanks.
Professor.
You too. Take care.
Thank you, Professor.
Bye-bye. Bye-bye.